Okay, so we are gonna do the problems of chapter number 4 from Halliday, Resnick and Walker 10th edition. So these are some of the sample problems and exercise problems that I've mentioned during the class. So here we have problem number 6. So in this problem you are given with the position vector. Remember, I won't care about the number of significant digits, but you have to do while doing these problems. So r is given as 3 ti hat minus 4t square j hat plus 2k hat, and you have to find velocity vector, definitely in inverted condition, and you have to find velocity at t is equal to 2 seconds. You have to find the magnitude of velocity, and you have to find the angle which this velocity vector makes with positive x-axis, that is theta. Okay, so to find the velocity vector, you just have, we know that this velocity vector is dr by dt. So differentiate this thing, and this will turn out to be 3 I hat minus 8t j hat in the unit of meter per second. And if we have to find velocity vector at t is equal to 2 seconds, this will be 3 I hat. Just put t equals 2 in this vector, and this is minus 16 j hat in unit of meter per second. So if you have to find this vector, you know how to do this. 3 square plus minus 16 square, and this will turn out to be 16.3 meter per second. And we know how to find theta, tangent inverse Vy over Vx, tangent inverse minus 16 over 3, theta equals minus 79.4 degree, or 180 minus 79.4, that is something around um, 101.6 degrees. So these are all the required answers. So let me just box this one and this one and this one. This is problem number now 6. So now I do problem number 7. So in problem number 7, you are given with the position vector r1, 5i minus 6j plus 2k when t1 equals to 0 second, and r2 minus 2i plus 8j hat minus 2k after 10 seconds, and you have to calculate the average velocity. Sorry, unit of temptation. And we know that V average equals delta R by delta T. This is R2 minus R1 over T2 minus T1. So by putting all of these values here, and you get the required answer. So VAVG will then be equal to minus 0.7 I hat plus 1.4 J hat minus 0.4 K hat in the units of meter per second. Next we have problem number 12. This problem number 12 is, so we are given with vector r1, that is 40 meter due east, and r2 40 meter due north, and velocity vector for the first position vector, that is 40, sorry, this is 10 meter per second due south, and similarly second velocity vector, which is 10 meter per second due east. t1 equals 30 second. So technically this is not given. So this is the difference or the time taken by the particle from this position vector to this position vector. So I should call this thing as t. So the time taken during this journey is just 30 seconds. Or you can say that t2 is equal to 30 seconds and t1 is equal to 0 seconds. And you have to calculate delta r, theta of delta r, and v average and theta of v average. So we have to calculate all of these equations. First we have to translate what these things are. So before translating this we need a coordinate system, um, um, and we know that the coordinate system should be like this. According to our convention, this is east, west, north, south. So now we can easily translate this equation into unit vectors or in the vector form. So this is just 40 I hat, this is 40 j hat, this is minus 10 j hat, this is 10 I hat. Now you can easily calculate all of the stuff. So delta r will just be equal to r2 minus r1. So this will be minus 40 I hat plus 40 j hat. I'm not gonna write the new units, but you know what these units are. And the magnitude of the position vector. So I forgot you have to calculate this magnitude. This. So delta r equals minus 40 square plus 40 square. So this will be 56.6 meter. And theta of delta r, so tangent inverse minus 40 over 40. So either this will be minus 45 degree or 135 degree. VAVG, average velocity, so delta R by delta T is, I'm not going to write this vector notation here. So this will be 56.6 over 30. So this will turn out to be 1.89 meter per second. Remember, for the sake of the unit vector notation, I just have to put this like this, 30.00. So in both of these vectors, will have three significant units. And importantly, the direction of, since we know that V average is delta R by delta T, so direction of V average is same as that of delta. So these are required answers. So this is problem number 12. So next we have problem number 15. In problem number 15 says that a particle leaves the origin with an initial velocity v naught. So v naught is velocity vector is um, 3 I hat in the units of meter per second, and acceleration vector is minus I minus 0.5 j hat. We have to calculate that when this particle, when it reaches, the particle reaches the maximum x, the height. So what will be velocity and what will be its what will be its position vector? Okay, so we know that from the two-dimensional motion that velocity can be written as v equals v naught plus at, and for x direction this will be v naught x plus axt, vy equals v naught y plus ayt. So this will be our equation number 1 and this will be our equation number 2. So to find velocity component we have to calculate the time, and we will find the time using some boundary condition or some final values. We know that at so when particle will reach its maximum height, then t will be t max, and at such point v of x will be 0. So, so at the maximum point in in the trajectory of projectile, the particle will be at rest. The horizontal component of the particle will be at rest. So this vector will be 0. Now equation number 1 will become 0 minus, so 0 is equal to 3 minus t. So t will be 3 seconds. So once we have calculated t, we can calculate the other components as well. So now by putting this in equation number 2, Vy will be minus 0.5. So because this factor is 0, as in this equation there is, so in this equation Vx is 3 while Vy is just 0. So minus 0.5 multiplied by 3, it will give us minus 1.5 meter per second. So this is the velocity of our object. Um, Now we have to find the position vector at this maximum location. Um, and we know that r equals v naught t plus 1 by 2 at square, second equation of motion. So we can translate this equation into its components. X of t is equal to v naught xt plus 1 by 2 axt square, y of t v naught y t plus 1 by 2 ay t square. Now we just have to put the values in the equations. So x of t is equal to, this vector will be 3, t is 3 plus 1 by 2 minus 1, t is 3 square. So this is 4.5 meters. And y of t will be, so v naught y is 0 plus 1 by 2 minus 0.5 into 3 square. So this will be minus 2.25 meter. So R maximum will be 4.50 I hat minus 2.25 J hat in the units of meter. So this is how we can find uh, different kinematical entities at the maximum location. Okay, next we have problem number 16. Though it's a very trivial problem. So we are given with a velocity vector 6t minus 4t square I hat plus 8j hat, and we have to calculate acceleration at t is equal to 3 seconds. So this can be easily computed. A is equal to dv by dt at t is equal to 3, at t is equal to 3. So by taking the derivative of this function, this will turn out to be 0. Then this is 6 minus 4 to 8t, and I hat, and this will be so 8 to 24. This is minus 18 I hat meter per second square. So this is the acceleration. So in the next part, so this is A and B. So in the next part, because it is asked that whether v can be zero or not in this situation. So we can see from this equation that this vector depends upon time. So if I put t equals to 0, then the 6 into 0 minus 4 into 0 square I hat plus 8j. Still, this still the component is not equal to 0, while this is 0. So it means velocity can't be vanished. So v cannot be 0. So there is no possible situation in which vector v can be 0, because vy is constant. Uh, Now it is asked that if the magnitude of velocity is 10, then so we have to calculate the time when the magnitude of velocity is 10 meter per second. So what we can do to find these things, we know that v is 6t minus 4t square plus 8 square. Now this vector is 10, so by taking the square, so this will be 6t minus 4t square plus 64. Simplify this equation and this will be our Quadratic equation 60 minus 40 square equals plus minus 6. So you know how to solve this. Solve this equation, you will get a number of solutions. Eradicate the solution with negative value because time can't be negative. So we'll just keep the positive value of t. So which will be t is equal to 2.25 seconds. So this is one of the possible solutions. Mathematically, there are a number of solutions possible, but physically time can't be negative, so we have only one solution which is possible. So the one with positive value of t. Next, we have problem number 22. So in problem number 22, we are given with a pretty different, pretty good situation that so there's a table. Let me draw it here. So this is a table at height h. This is the surface of the floor, and at this point we have a ball, and this ball is traveling in some forward direction with some initial velocity v, and it hits the floor at this point. So we call this, it hits the floor at this point. So the distance between edge of the table and this point is d. So we are given with some of the initial values, such that height of the table is or y, so 1.2 meter. So I call this height as h due to some conventional issues that we followed in the book. And this distance d is equal to 1.52 meters. So now the question is, how long is the ball in the air? So we have to calculate the time which ball stayed with us, which ball stayed in the air. So this can be calculated from Newton's equation of motion. Y is equal to v naught t minus 1 by 2 gt square. Ball is traveling in the horizontal direction, so this vector will be 0. So you can find t as minus 2y over g. So 2 into minus 1.20, this is g is 9.8, so this will be 0.495 seconds. So in the second part, you have to calculate what is the speed at the instant it leaves the table. So we know that this is the instant when the ball leaves the table. So what is the speed at this point? At the very time it leaves the table. So that can be calculated very easily using v naught equals x over t. So x is 1.52, 0.495. So this will be 3.07 meter per second. So this is how you will find time of any object in this situation. So problem number 23. So in this situation, we are given with a projectile at a height of 45 meters, and which is thrown with a velocity of 250 meters per second. So I think this problem is about a bullet which is fired from a gun with speed this. You can check it from the book. I'm not going to read the statements in detail. Um, So again, we have to find the time the projectile remain in the air. So we have to calculate the time. Again, by using Newton's equation of motion, y is equal to 1 by 2 gt square. So this will be t is equal to 2y of g. Just put the values and t equals. And you have to find the horizontal distance um, from the firing point to the striking point, and this will surely be the range of the projectile. And the range of the projectile is just v naught x multiplied by t. So this vector is 250 multiplied by 3.03. So range will just be 29.7 meters. Now we have to find the magnitude of the vertical component. Sorry, sorry for that. So Vy equals V naught y plus AYT. So this is V naught sine theta naught plus G. So angle theta will be zero as the bullet was fired horizontally. So this will just be 0 degree, and this will be G times T. So will just be equal to G T. So by putting the value 9.8 multiplied by 3.03, so you will get Vy to be. I think I made a mistake here. Um, I just checked. This answer isn't. Um, this answer isn't equal to 29%. This is 758 meters, while this is 29.7 meter per second. So again, this is one of the possible scenarios of a projectile motion. That um, usually these are one of the quantities that you have to calculate in your problems.